That's better. Okay. So I wasn't supposed to be doing this talk. Triano, he's in bed, sick at the moment. So I worked with him at noon. I was there for about 5 months. You can ask me about that later over pizza. And he was going to do a far better talk than I'm doing now. His one was really great, but it was going to be far more technical. I'm going to do one from a slightly different angle. He was the architect, so very, very technical. I was more in management at the time, so I was more getting shouted at by my boss, Steven, you need to deliver this, and then working with the team to try and deliver something. So I arrived at noon, 15th of January, walked into, I don't know, it was like a startup. They'd only been going for about a year, but really technology had only been going for about 6 months. And there were 3 burning issues. One was, why is it taking a DevOps to go and sit next to every single developer to do a release? We've only got 3 DevOps engineers. Why have I got this bottleneck? Why? I've got 70 developers. They all want to release a couple of times a day, and yet I can release like once every couple of days because some poor DevOps has to wheel their chair around to a developer, sit next to him, type magical commands into some sort of black box, and then you get a deployment coming out of the system. We also had these other issues. Nobody knew when stuff was broken. Nobody could easily identify what was going wrong. I did a talk, I think the first meetup, about how we solved some of that stuff. And then we had the ongoing thing of security. Lots of people interested in Noon, like trying to hack in, seeing what, I'm not sure why, it's not that exciting. So this talk is about how we solved that initial thing, the biggest problem they had. How do we stop needing a DevOps person to go and babysit a developer on every single release? How do we get it so that the developer can do it on their own, but not have a complete Wild West show? You know, so that they don't. Not every single one of those 70 developers is breaking it in a different way. So that's the reason for a container platform, I think. Anyway, they talk about Kubernetes and DCOS, and usually it's technical masturbation. You know, you get it because it's cool to play with, certainly for the developers and the teams. Other people look at it and they say, oh, it's the new buzzword, we should play with the new toys. Maybe we're going to get like more compressed number of machines on. No, it's none of that stuff. This solves that problem, right? You've got a standard platform that you can give the developers and they can ship their own code. That's the only reason for using one of these systems. And they can do it in a consistent way. Because you could build this, I could write this in Bash, right? I could get something hacked up and I'd get it working and it would break. And when I came to give that to another development team or another developer, it just wouldn't scale, right? So this is about getting developers to self-service their own deployments all the way from their laptop into production through different environments in a safe way. So it's tested, and that they've gone through all the usual checkboxes. So developers sitting there, instead of asking a human to do this sort of stuff for them, how do we give them some source files? You know, they're developers. They like to type into text boxes and upload it to source control repositories and press buttons or have it automatically happen. So the sorts of things that you'd want to do as a developer, obviously, you've got your code. You probably want to start building that into a Docker container, something that's got all of your dependencies in a binary that you can push up somewhere and store it in a registry. You've probably got some compose files already for running it locally on your laptop, or at least parts of the service that will fit within your RAM on your MacBook. And then you want to try to somehow get that container into the test environments, into staging, into production, but have it go through some kind of pipeline, right? So it's going to run some tests. The system's going to tell you, and we had a couple of guys sort of try to spin up containers with 128 gigabytes of RAM, give it 64 cores. You want the system to kind of tell you, stop being stupid, use some decent amounts. So let's say you're using it properly. As a developer, you want your service, new Java service or a new C# or whatever, doesn't matter. You put it into a container, and you now want that running in staging so that you can see what it looks like, maybe do some tests before you push it to production. So you want to say, okay, give me like 8 gigs of RAM, give me 3 of them, I'd quite like it if Amazon had a problem, I didn't have a problem. So let's put it in 2 different availability zones. You know, 1 in A, 2 in B, or maybe stripe it across 3. Is normally they have to talk to something. Like you'll need your microservice to talk to another couple of microservices. So you'll edit your environment variables and you'll say, this is the name of the service in staging, this is the name of the service in production, those types of things. And any other databases that they need, things like MySQL, Cassandra, all the other bits, you can give them names yourself. You don't need to talk to a DevOps guy. Why would you? You know the list of things from a wiki page. Also, running the right versions, generally important. You know, you probably want to release the next one that you tested on your laptop, and then subsequently push the next one. And do that in such a way that you're not having to sit there and sort of race the computer, you know, so that your users don't see any downtime. Wouldn't it be nice if you could just say, deploy this, and it would be clever enough to keep the old one running, deploy the new one, make sure that the new one works before it kills the old one off. And it drains all the connections and does all that stuff for you. So yeah, container platforms do that. And of course, if they break, restart. That's the main bit. So, I mean, you can do that. There are Kubernetes, you can do it. DCOS, you can do it. Docker Swarm, you can do it. All these different container platforms. You have a file, just a YAML file in the root of your repository. You start to describe what your service is. You know, 3 instances, 1 CPU, 8 gigs of memory. Does it need any local disk? You can start adding, in DCOS, this is constraints. So they're kind of like tags that you put on physical machines. As you install DCOS, you give it some configuration. You might say that these physical hosts that you've installed or infrastructure machines, these ones are for production, these ones are for staging, these ones are for high I/O, these ones are for high CPU, and you can start to decorate your physical boxes with constraints. You advertise them in a wiki page of developers and they go, oh, let's play with those. Let's edit our YAML, and now we can control as developers, you know, if our application needs more CPU or if it needs more memory or I/O, or if it's a staging box or if it's a production box, or even separating out different environments. We had the payments team were not happy being mixed in with the e-commerce team. Not sure why, but we were separating stuff out. And we were even separating stuff out in terms of resiliency. So obviously Amazon, I've always said, is a tax on the stupid. If you're using it like a data center, you're wasting a lot of money. If you're using it like a plug socket and you turn the power on and off when you're using it, that's the correct way. The easiest way, obviously not everybody can do that. Some of our applications were built the old-fashioned way. They had to be running all the time. They didn't scale. We put those onto dedicated instances and we tagged those dedicated. So if you're running an old-fashioned application where only one can run and you need to come back because it's technical debt and fix it, tag that dedicated. Those containers will spin up on boxes that sit there forever and never change. If you're writing new stuff in a proper way, i.e. it can spin up and down and you don't care if things break, you can tag those as spot. Now your Docker containers spin up on machines that are ephemeral in auto-scaling groups. You pay a lot less for those. You pay 80% for spot instances. So if you can build your applications properly, you can, as a developer, choose to be kind to the company and stop the Amazon sprawl. So that describes the application, you know, what it needs to talk to, what it needs to run. You also have this idea of describing the deployment. So we were using GitLab. They do a nice CI. You could use Jenkins, Travis, Circle. It's all the same, really. All of them nowadays, anyway, all the modern stuff, even Jenkins, has the ability to put a YAML file in the root of your repository. When you hook the repository up to your build server, it will look at the YAML file and that will control the build. Right? So within this one YAML file, you can tell it how to build stuff. You can copy and paste sections into that YAML file for deploy to test, deploy to staging, deploy to production. You can tell it which registries to use. And once you've done all of that stuff, it gives you pretty buttons. Right? Just by generating little bits of YAML, the interface will give you it. You can sell it upon check-in of my new code, automatically build, automatically push into staging, so that you can do some tests, automatically test. If tests pass, automatically push into pre-production. If that works, pop me up a message in Slack to say I'm finished, and you can either reply to the Slack bot, QBot, and it will do the production deploy for you, or you can go into the interface and press the button. So this lets developers control anything they want. Some of the teams they only had deploys to production. Like web front end, you can test it locally. There's no difference between a browser in production and your local one if you're testing locally. If you're rolling out a big feature for the web, why not put it behind a feature flag? I mean, it's very easy to toggle feature flags on and off the web. If you're talking about the supply chain, where if you make a mistake, some of these poor guys in the warehouse have to pick up 20 products and put them back on the lorry and then put them back through the entire process again, that wastes days. You tend to be a bit more careful with that stuff. You know, it's not the same as, oh, we got the wrong color on the button. This is the data's wrong. We have to go and redo it all again. Those guys had 3 or 4 different test environments. They were testing it, but again, they decide their own stuff, right? You give them the ability to configure up the number of environments they want. They can put them on whatever format machine they want. They decide. You don't have a DevOps guy involved in that stuff. We moved it a bit beyond that. So, you know, as a developer, you describe your application. You can describe how you deploy it. In the new world of thinking, you not only do you build it, but you run it. You know, your job doesn't stop at pushing it in production. You take the pager home, or ideally you get threatened to take the pager home. And you build your application so you never get woken up. That's the trick of DevOps. So you build it, you run it, you support it through its life cycle, and for that you need to be able to configure your own rules. So each of the developers are able to, as soon as the application spins up on the container platform, the container platform is configured to automatically scrape a /metrics endpoint on every application. So it's automatically getting all of their metrics out of their applications already. All they need to do, go into Grafana, start to build dashboards, create some queries, and you can take those exact same queries, copy and paste them into some YAML, and we have a system that scans the YAML files via continuous delivery by the CI system, and it will automatically alert you based upon this stuff. So again, you don't need a DevOps person to come and sit next to you. You know, you could wake up one morning, decide, I'd quite like a new microservice today. Well, actually, I'll take you through that stuff. So this is the workflow, right? I mean, you're a developer. You come in one morning, there's a new Scrum team. You decide you'd like to build a new microservice for doing whatever. Doesn't matter what it is. You create a new Git repository. You clone a skeleton of one that we just use as a template. It includes the 3 files in the root. Probably includes a whole bunch of Docker stuff to build the Docker things. It probably includes the framework that you're using. So we had one for Scala, but I think we're also looking to build one for Node.js. You basically just clone it in. You can pretty much immediately, once you've twiddled about with some variables in 3 files, which takes about 20 minutes, you can immediately then start deploying your application into production or staging or wherever you want to do within that period of time. You know, from the setup of what you're planning to do to it being a microservice on the platform is half a day, maybe less. From that point, you're just working on writing code. You're writing code, you're letting it automatically deploy, and you're pressing buttons to deploy it to production. So, and this is a fairly common scenario. I've been working with other companies. I mean, we kind of discovered this on our own, you know, the idea that you'd have a file that would do your application, a file that would do your deployments, and a file that would do your rules. Other companies are now sort of doing this. This is becoming sort of standard. So, the bit that we're talking about when we're talking about the container platform, we're talking about this Marathon JSON in our case. We're using DCOS, which is a mixture of Marathon and Mesos and Chronos and all these different buzzwords all mixed together. This is the file that talks to the container platform. So when I joined, we were running 70 microservices. Within 5 months, we'd gone from 70 to 233. I hadn't been involved in any of those past about 80. I think I was there, we painfully created about another 10 microservices. These poor 3 DevOps engineers helping out 70 developers, which in the developer count increased to 150 by the time it all went wrong. But yeah, we got it up to about 233 running things in production, and that was skyrocketing. You know, you've given these guys the ability to do whatever they want on the platform, and then they were having sort of architectural reviews of how things fitted together, slowly evolving towards you know, a good system. So when I got there, DCOS was already chosen, it was already installed. I know Kubernetes is the favorite nowadays, it's the more popular one. We were already launched by the time, well, not launched, but it was already running and people were accepting deliveries from the warehouse. I wasn't allowed to come in and turn it all off. and, and put a new thing in. So I don't know how well Kubernetes would have done. I have just picked up a project where I'll be doing the same thing on Kubernetes. So I left actually 2 months ago, and I know that Noon had kicked off a project on Kubernetes, which was why in the initial blurb, Triano, who's still there, was going to talk about this work that we'd done, plus the work that he's done over the last 2 weeks of Kubernetes, and give you a good talk. Unfortunately, you're left with this. So you get like a bit. You'll get the DCOS part from me because I don't know the Kubernetes bit. But maybe once I've done this other project, I'll come back and do a talk about Kubernetes and how different it was. So in terms of DCOS, what that gives you, as I said before, you create this JSON file which describes your application. That's what DCOS wants to consume. It wants to know how many CPUs, how much memory, what it should run on, all the environment variables, what the containers should connect up to. And then it will, once you've posted that in using GitLab as your executor, it will then do the rest of the work for its entire life, right? So it has a few different components, but none of that important. So, what is it? I mean, you can run DCOS or Kubernetes or all of these things in loads of different ways. You can run them on Amazon, on Azure. You can go out and build your own data center and install it on bare metal. What it really is it's normally some kind of Linux operating system. You install a bunch of services on top of them. Generally, because this stuff is all around running containers across different hosts, it is a distributed system. So you have masters and you have slaves, and some of them do different things, and they're generally sort of connected together in weird and wonderful ways. But we built ours. The initial version of stuff at Noon was built using the CloudFormation template. That wasn't a great idea. If you want to edit the CloudFormation template, it's got a habit of deleting everything and recreating it. So we kind of did our custom stuff. So we rebuilt all of the config in Terraform. We slowly rebuilt the entire cluster. And we were using Ansible for configuring up the Linux boxes that ran the different services, different roles. And we were slowly working on the architecture inside Amazon to reduce costs. We were trying to get some of the cluster running on the expensive bits, some of the cluster running on the less expensive bits, but allowing developers to choose where they want to put their stuff. So I don't know if you can see any of this. What we ended up in the end was 2 different VPCs. So we actually had 2 different Amazon accounts. It's fairly normal. You have an account maybe for billing, and then below the billing account you might have like a development account and a production account. You don't really want developers logging into any Amazon production accounts if you can get away with it, or if you get hacked in the dev account, you don't really want the hackers to have access to production. So we kept 2 accounts, same region, everything else. And to save a bit of money, we ran the main app, so the Marathon LBs, the master nodes. We had 5 of those. We ran basically the cluster in production, but we created VPC peering links into development in order to spin up resources in the development environment. So you had a single interface for the platform, but you could determine via these constraints whereabouts the containers would run. And if you spun up your container and you told it the constraint was in the development VPC, it wouldn't, even if you used the wrong settings, it wouldn't be able to get to production data. It would be isolated. So we had that stuff going on. We had clusters of auto-scaling spot instances. We had on-demand instances, fixed scaling instances. Everything comes into DCOS via public nodes. It's kind of, they bundle it up. You can in Marathon do it differently, but they package it up into like an easy-to-use, easy architected thing. You run the installer, you tell it these ones are public. It's got like a little wrapped HA proxy script that lets internet traffic in, and that routes it dynamically to the containers inside. And in terms of what we were running, when I first got into Noon, everything. We were running Cassandra, Kafka, MySQL, Postgres, Redis. There was loads of stuff on it. We were moving stuff around a lot, and what we found was actually grouping the stateless stuff together made things a lot easier when you're changing what is effectively quite new technology, right? I mean, we're trying to upgrade DCOS to keep up with the latest and greatest pretty much on a weekly basis. And then you've got this stateful stuff, and we were just at the very beginning of these frameworks. So DCOS positions itself as run stateful applications, and it has these frameworks. But the frameworks are really about, especially for the Hadoop and the other things, they self-heal things. which is great. But then when something goes wrong, you've got to fix the self-healing and the thing that's broken. And we were having a lot of issues with, we'd almost get something fixed and it would jump in and try and fix it. And then you're battling against this immune system. So we decided, let's just remove all the stateful stuff off. Let's get rid of Cassandra. Let's just put it onto bog standard EC2. Let's move the Kafka off onto EC2. Let's just have DCOS as a platform just for stateless stuff. And actually, that's what Kubernetes is, right? I mean, Kubernetes is kind of a cut-down version specifically for web apps. Only really does stateless things. And that's what we gravitated towards. Just only put the stuff that your developers are writing on the container platform. It'll make your life a lot easier. So yeah, obviously one of the big problems that a lot of this stuff's had over its lifetime is how do you get all of these things that pop up on different boxes, sometimes in different availability zones, with different settings? How do you actually get them to talk to each other? Like you've got like a moving target. It's on this box with this network card in this VLAN. How do they actually communicate together? For a long time, I remember there was very stupid stuff going on with IP tables and Nginx. Like you'd put all of these different dodgy containers that would route stuff on different boxes. And yeah, luckily that's kind of finished now. So when I came in, we were putting in LinkerD. So LinkerD is quite cool. You can, it's a container. It's basically Nginx, but it's got some really cool stuff around the outside. You tell LinkerD as part of the container platform, any box, any physical node that I spin up as some compute resource for the Docker containers, run me one instance on that box of LinkerD. It will bind to the local host network controller and open up a port. I forget what the port is. But effectively, then you can figure up all of your applications in your repo just to set the proxy up to proxy through localhost : 90/100 or something. I forgot the proxy port. Effectively, wherever your container splits up on the entire platform, it will connect to localhost 90/100. It will then proxy all requests through the local hole, and that proxy layer then contains the network routing. Right? These all act as a service mesh. They all talk to each other. You've got some cool stuff that's going on. There's a process called named that runs on a couple of the masters. And what that does is it dynamically queries DCOS, and it looks at what namespaces your containers are deployed in and will dynamically generate you almost like a DNS. Right? So now if you've provisioned your services to start up in a namespace like prod.service1.node1 or whatever you want to call it, you just within your config just use that dot notation when you're talking to things. It's very easy. That way you don't have to even know what somebody's called their service. You just look in the DCOS GUI and you can just see whereabouts it is and just construct your path. As that moves around all the different boxes, it's fine. It will just route it dynamically. It knows where the container is. On Kubernetes, you've got Istio. I've not played with it. I was going to have a play with it, but that seems like the other bit, the other cool stuff for Kubernetes. In terms of what you get, though, once you've put this on, obviously now you've got all your web traffic, all your application traffic going through a proxy layer at layer 7. So now you can do some really cool stuff. You can extract exactly what's happening. You can put it into Zipkin. You can trace every request. You get cool Grafana dashboards. You can basically track every request through every service as part of its lifetime for free without having to put all of these correlation IDs and other weird stuff in. So that was quite cool. And I did promise you some Kubernetes and Istio in the thing, but I know nothing about them. I was going to Google and pretend, but I thought you guys might find out. That's it. Any questions? Yes. I mean, so I missed that. So why was LinkerD chosen over HA proxy? Okay. So HA proxy we were still using. It's bundled up as part of Marathon LB. So that's on the front end. We were using that as pretty much a layer, is it layer 4 proxy, I think. So that was quite good at getting traffic in from the load balancer. The ELB on the outside would come in. It would dynamically talk to DCOS to find all of the things. But they were running on public nodes. Right? So that's not really part of the internal cluster. What we needed to do, we could have run Marathon LB internally as well. we wouldn't have got all of this cool DTAB routing. We wouldn't have got Zipkin tracing. We wouldn't have got all the other things. We would have got basically HA proxy, just routing stuff between them. So, and also this is a lot easier. If we'd have chosen Marathon LB, you have to designate like 2 nodes to running it, and then it can talk to Marathon. It can talk to it. With this way, it's a mesh. It talks to localhost and it finds the quickest route. So it's a bit cooler. Any other? Actually, go ahead.
Okay, I'd like to ask you about the communication between that containers. The ideal solution, you say that every container contains microservices, right? So microservice-based container.
Yeah.
Then the microservices, as the microservice contains its data store and it contains multiple. I mean, from end to end as a service. Like if you have a service called user,
yeah.
Service contains the data store as well contains the.
No. So the containers would contain the application, okay. And they would be configured to talk to stateful stores like Cassandra and Kafka, but that was off of DCOS. That was on the outside.
So why you didn't store the microservice in one container?
So
to simulate really microservice or a service.
Yeah, the problem with storing state in a container is, let's say you kill it. Now you've got to work out how to replicate that data to another box as it spins up. Remember, you kill the container, it might spin up on node 1 or node 20. So if you start having basically data within the container that changes, you've now got this problem of, this one's running here, but it died. I've got to like vMotion the data over to somewhere else, and that's not really the way that containers work, right? It dies. So the microservice architecture they all talk about is making sure that each of your services has its own data, right? And that's the correct way. But that doesn't mean that it needs its own data within the container. It doesn't even mean it needs its own database. It means that when you query for the data of a microservice, you query for that service's data through another service, and it might actually be a table in a shared database, right? So we were looking to consolidate to save costs. So we had multi-AZ RDS, one for Postgres, one for MySQL, but only one. And we were making sure that our domain model for the data was separated within that database, but they'd all talk to that database.
So then how to guarantee that if you have like testing environment and then you move to production, that you simulate the same things on the test, move again to the production?
Yep.
If you don't have one container contains everything in one container, you cannot guarantee that the same settings in those.
Yeah, it's the age-old quandary, isn't it? This is why really the only good test is production, right? This is where you get to in the end. Everything before production is really just mucking about, right? Because you can only really test things in production. So you'd have to move slightly differently. Trunk-based development, trying to make your releases much smaller, doing backward compatible data things, and try to put as much focus in production as you can and only use non-production testing for stuff that really matters. But yeah, there's no easy way. Containers don't change or modify that.
So how you can register new services if you have like single service or single microservices, you need multiple instances from the same service. Then you need to register based on the request.
Okay, yeah, so the way that it works, with so stock DCOS comes with L4LB, which basically means it's a layer 4 load balancer. When you spin up a container, you can give it a virtual address, and they'll all bind to the virtual address. So for one service, you might say, I want 3 containers. Here's my VIP name. My VIP name is this service name. Even though these 3 containers all spin up on 3 different boxes, it will dynamically route them through the layer 4 load balancer. It's the same thing as what LinkerD does as well.
The versions like that? The versioning between that?
So the way that the version works is you post a Docker image, normally with a tag as the version, okay? And the service, the container service, will run each of the containers on that particular version. Now, when you want to upgrade the version, you have to be quite careful because you need to make sure that your application can run alongside older versions. Right? So when you post the new version, it can spin up as version, let's say you've got 3 version 1s running. You post version 2, it will spin up a new version 2 alongside your 3 version 1s. Right? Assuming that comes up, it will then kill one of the old ones and spin up a new one in its place. So you end up duplicating them out. But yeah, this is to use these platforms, you have to write them as 12-factor apps. You know, otherwise you have to go through and use different things. So there is a deployment mechanism that in the YAML file, you can tell it basically deployment strategy earliest first, or deployment strategy, I forgot the name of it. But with a different deployment strategy, it will go, right, this application hasn't really been written as a 12-factor app. It's not designed to run multiple versions alongside each other at the same time. It's designed to basically be upgraded in the old-fashioned way, and the container platform will turn off the old one and turn on the new one. Right? Now that's obviously not zero downtime. So, but yeah, you can control the deployment strategy through the YAML files as well. But
one last question. Sorry.
yeah.
So now you have a lot of containers and microservices are communicating together, and then once you say that microservices could be hosted in different containers,
Yep.
then the amount of data traveling between such a massive amount of data,
Yep.
then how much cost you will pay for such a system?
So that was really the cheapest bit. The 99% of the Amazon bill was compute. Right? I don't know if you guys noticed that, but all of my build I've ever worked at in any company was always instances. It was never network. Maybe I worked at the wrong companies, but it was always just people have left on C3.88 larges, and it's costing us $3,000 a month. The network wasn't ever a problem. Now, one of the cool bits that you do get with LinkerD, and we had this, I had a better picture than this. It will show you the latency between each of the services if you hover. It will show you literally every single transaction that's happened between every single microservice that you've got. And I remember at noon we were running 233 microservices. We were load testing using Flood.io to simulate 1,000 orders a second on the system, and the latency between those was still microseconds. It was still like 30 or 40, milliseconds. It was still like, you know, really tiny amounts. The network latency was bigger than the out of.
So the cost of the money cost, the cost of that running such a system,
Yeah.
even with load testing, is not so high.
It's negligible, yeah. The actual calls themselves are nothing really. We were paying more for the Java RAM usage on the machines and keeping those things running.
You can orchestrate the sorting of the data, sorting the data.
Yeah, of course.
Like moving like you can orchestrate that.
You can do lots of things with LinkerD. I mean, if you read the manual, there's lots of options there. But no, the cost of the data between the service mesh, negligible, like a few pennies. Any more? Take one more. Yeah. So the answer to the question was, how do you store credential secrets? DCOS comes with a secret store. They've taken Vault and they've wrapped it up and they have it in there. So generally the credentials were looked after by DevOps themselves. We would insert them into DCOS, and you could reference the variables within your YAML file that you would paste as secrets. So the secrets would never go into the box. They would stay within the DCOS vault, basically. It wasn't a great, so we were looking to move off onto Vault, but it was just too simple. For yeah, so I mean, we were looking at the time. So the question was around, you've got containers that spin up and down that can scale. You've obviously then got another layer below that that can scale, the auto-scaling groups on spot instances as well, so they're even more fragile. How do you make sure that users aren't affected? We were looking at doing things like running the first version of the container on non-spot and allowing you to burst into spot so that you keep the service running and you could lose things. How do you handle graceful degradation? We were running automatic sort of curls in a while true loop against it and killing off containers. And the combination of HA proxy in Marathon LB and LinkerD was actually able to never drop any messages to the service as we were killing stuff up and down. So it seemed to work pretty well. Cool, thanks. All right, that's probably it. I'll hand over to Sven.